Hello again, everybody. This is another video, and this is about the alternator. If you saw before, I made a quick video where to measure with a clamp meter the output of the alternator. Now, if you remember before, I just did a video about a starter motor. Well, if you look at the wires over here, gray, and then it says charging circuit, okay? Black and orange wire goes to the charging, and then there's a gray. This is the same thing as this. Compare it. See it? This gray, black and orange goes to the alternator, and then there's the fuse, the same fuse. So it's the same circuit. As you see over here, it says charging circuit. Here's the charging circuit it goes to. Now, current flows from here to here to here to the alternator. And there's probably a regulator over here. What's a regulator? Regulator means it wants to keep the voltage constant at the same level regardless of all the accessories that you put on it. Because a voltage from a power source, in this case, this is an AC generator, and it's rectified by diodes to DC. We need DC to replenish the battery because the battery just gave all the current when you cranked it. But however, since this is 12 volts, this charging always has to be higher than the voltage you are charging. So if this is 12 volts, this has to be 13, 14 volts. Can't have a 12 volts charging a 12 volt. Also, like we said, the accessories, the fuel injectors, the ignition coil module, all these things need current. When you put a load on something, let's say I put on the blower motor, any source, if it doesn't have a regulator, the voltage will drop. You don't want the voltage to drop. You want the voltage to be constant. It might be 13.5, it might be 14. It doesn't matter. If it's colder outside, some alternators will be higher. And then eventually, it'll come down. The voltage will come down. If you ever notice that on the gauge. Now, the current flows to this. This is probably a regulator in here. And the regulator has transistors and other components. It needs that B plus coming in. Obviously, when you crank the starter, you're cranking the pulleys, you're cranking the crankshaft, the camshaft, and the pulleys. That belt is turning the pulley, and that's when the rotor and the stator create the magnetic field inside the alternator. What happens is, as that happens, that voltage is a voltage over here at B plus, and it's a red wire, red thick wire that you saw I put a clamp around. Now, why did I put a clamp around there? As I explained before, I'm just not happy enough to see the voltage if it's constant. I could put on the lights and I'll see the voltage is still on. I'll look in the gauge on the instrument panel that you have inside your car on the dashboard. I'll put on the lights, I'll put on the blower motor, and it'll be at 14 volts. Fine, that's great. I want to see the current. As you put on the accessories, more current should be derived from this alternator, as you saw in the video. Sometimes it was 12 amps, then 30 amps, whatever, depending on the accessory. If there's a computer, and you don't see it over here, if there's a computer, the computer gives the command. When I put on the switch, or when I put on the blower motor, when I put on the lights, it gives a command almost to the alternator, tell it, you know what, give more current. That command is in a pulse. It could be 100 hertz, 140 hertz. That's not enough information for me to tell me if when I go to the computer and I put a oscilloscope, whatever it is, and I'll see the pulse, that's not good enough for me to tell me if the alternator is working. If the computer is giving a command, let's say I put on the blower motor on high speed, maybe 20, 25 amps, right? It's a lot of amps. Those fuses are rated high. The blower motor takes a lot of current. That's why I use that as an example. Let's say I put it on 2,000 RPM, right? What am I doing? I'm putting on the fuel injectors longer because they have to give more fuel. That means you have to give more current. So more current means if I put my clamp meter over here, which I did, and I showed you, I put the clamp meter over here on amps, I saw the current changing. as I put on the accessories, as I put on the blower, as I put on the lights. That tells me the computer gave the command. The rotor and the stator is creating the magnetic field to create more current. That tells me all of this is working. By seeing a pulse from the computer doesn't tell me anything. It just tells me that the wire is good and the computer is good. What about the alternator? That's why I stress the point. Put a clamp meter out here. Make sure you get the current changing when you put accessories on. Okay? I can't stress that point enough. Now, this is a basic circuit over here. That's why once you start, the engine starts turning. This will feed back the battery. Of course, the battery is connected to the fuse box and everything else, and it'll take over the accessories. Now, this one over here, as you always see, this one over here is just the light, the charge indicator, until this starts spinning to create enough voltage, and then this light goes out. How do I know that this fuse is good? By the light going on. If the light goes on, this tells me that the fuse is good. That tells me also this wire is good. Right? And this tells me also that whatever is in here, giving this a ground, whatever it is also good in here. If this light doesn't come on, even though my alternator output is good, that tells me maybe the light is bad or the fuse is bad. Not really important to me. This is just an indicator that you're getting the alternator output. Anyway, like I said, thanks for watching. And hopefully I'll see you in the next one, which will be about continuity and LCM modules, as I was asked. Again, thanks for the subscribers. I'm shocked that I have those many. The views, what can you say about that, right? It's amazing YouTube doesn't take away views from me instead of giving me views with this channel. Well, you just keep on pushing, right? Okay, thanks for watching, and I think you'll find the one with continuity very interesting. Thanks.